Friends, good morning to everyone. During the last few presentations, we have discussed about the carbon ions, what are it, how are they formed, what are their nature, what are its character features, and also we studied about the factors affecting the carbon ions stabilization. We have seen that inductive effect, positive resonance effect, hybridization of the carbon, and the aromaticity are the factors which are having stability to the carbon ions. In this presentation, let us discuss about the reactions of carbon ions. What type of reactions carbon ions can undergo? Similar to that of carbocations, it can undergo addition reaction. Before that, it can undergo substitution reaction. As carbon ion is electron rich, it can act as a nucleophile and react with a positive species like alkyl halides. And it can act as a strong base. A base is a electron donor. As per Lewis acid base theory, a base is a proton acceptor as per Bronsted theory. It can donate electrons to hydrogen and forms the bond with H plus, and hence it is a base. It can donate the electrons to an alkyl halide. The leaving group leaves and undergo substitution reaction. Hence, it can undergo substitution reaction. As it is electron rich, it donates electrons to an electron deficient carbon of the alkyl halide. The leaving group, that halogen, leaves away, and L minus, that is the leaving group, is replaced by Z minus, that is the carbon ion. It can undergo elimination reaction. A base can abstract a proton and it gives rise to a carbon ion. This carbon ion which is formed is unstable. This excess electrons is given to the adjacent carbon in which it has an easy leaving group. Once these electrons are donated to this adjacent carbon, a double bond is formed and carbon has to maintain its tetravalency, and hence it kicks off X as X minus and a alkene is formed. The carbon ion undergo elimination reaction by following E1CB mechanism. E1CB mechanism is followed when a conjugate base is formed by CH bond breaking, and this intermediate assists in leaving the leaving group and it gives rise to an alkene. Dehydration of aldol follows E1CB mechanism. E1CB mechanism is followed when a there is an electron withdrawing group adjacent to the carbon ion and a difficult leaving group like OH. Another reaction which it can follow is addition reaction. The special type of addition reaction it follows, that is condensation reaction. What is the difference between this condensation and addition? Addition takes place between two different molecules. But in condensation, like molecule adds to another like molecule. For example, in aldol condensation, two acetaldehydes or the two ketones or two aldehydes having alpha hydrogens, they react together in the presence of a base to give alpha beta unsaturated aldehyde. Self addition is the condensation reaction. Let us see the aldol condensation. Acetaldehyde, this is having alpha hydrogens, means it has hydrogens on the alpha carbon, that is the carbon which is adjacent to the aldehyde group. If I treat with a base like OH minus, this carbon is acidic enough to lose the proton and base is basic enough to abstract the proton. It abstracts the proton from the alpha carbon. Once the proton is abstracted, the excess electrons is left off to the carbon to giving rise to a carbene ion. And this carbene ion is stabilized by the adjacent carbonyl group. Then the carbene ion which is formed attacks on the carbonyl carbon of the another acetaldehyde group. Once the attack takes place on the carbonyl carbon has to maintain its tetravalency. The pi electrons moves onto the oxygen, giving rise to an anion, oxygen anion. It is unstable. Hence, to maintain its stability, it combines with H plus from the water molecule and it becomes alcoholic. It has both alcoholic group and aldehyde group in the molecule. That's why it is called as aldol. Beta hydroxy carbonyl compounds are aldols. Let us look into another condensation reaction, Clason's condensation. Clason's condensation is a condensation reaction in which a beta keto ester is formed. In case of aldol condensation, a beta keto aldehyde is formed or a beta ketone is formed. In case of Clason's condensation, beta keto esters are formed by reaction with two carboxylic esters in the presence of the base. I take ethyl acetate, an ester, and treat with a strong base like sodium alkoxide. The O minus abstract the proton from the alpha carbon, giving rise to a carbene ion. As the carbene is unstable, it reacts onto the carbonyl carbon of the another ester. The electron rich carbonyl carbon is positive. This electron rich carbon forms bond with carbonyl carbon. It has to maintain its tetravalency. Pi electrons moves onto oxygen. This becomes O minus. O minus anion, oxygen ion is unstable. So what it does? It moves back, gives back the electron to the carbonyl. It is having an easy leaving group, ethoxy group, and the carbon oxygen bond breaks and ethoxy leaves as ethanol, giving rise to a beta keto esters. This is Clason's condensation. The modified form of Clason's condensation is Dickman condensation. Dickman condensation is an intramolecular condensation reaction of a diester to give cyclic beta keto ester in presence of the base. I take a diester, it is having COOMe here and CH2COOMe here. It's a diester. I treat with a base, it abstracts the proton from the alpha carbon, giving rise to a carbene ion. The carbene ion which is formed attacks on the carbonyl carbon of the second ester group which is present in the molecule. Once it attacks on the carbonyl carbon, methoxy gets kicked off as methanol and I get a cyclic ketone, beta keto ester. This is Dickman condensation. In case of Clason's condensation, two esters react. In case of Dickman condensation, a diester reacts. In case of aldol condensation or in case of Clason's condensation, the carbene ion formed attack to the next ester. But here there are two ester groups in the same molecule. Hence, it forms a cyclic beta keto ester. Addition reaction, it can undergo Michael addition. The carbene ion diethyl melanate, when I treat with carbene ion, because when I treat with a base I get a carbene ion, and this carbene ion can act as a nucleophile and add across a carbon-carbon double bond in alpha-beta unsaturated ketones. This electron-rich carbon forms bond with the carbon over here. Pi electrons moves over to this carbon and this becomes O minus and it gets added up. It can undergo Michael addition reaction. In the next class or in the next presentation, we can deal with the rearrangement reactions exhibited by our carbene ions. Till then, have a nice day. Thank you.